Yeah, I have a bit of a hybrid background. I would say I'm about half computer science, machine learning, AI, and then the other half focused on economics and specifically development economics or the economics of poverty. And there's a lot of interest right now in how AI, machine learning, and related technologies can be used for social good or social impact. My work tends to focus on how it can be used in global development. Maybe switch to the next slide, please. So this is just like a scattering of some of the areas that I have done work in. Rather than give the 10,000-foot view, I thought it would make sense to focus mostly on one project so you can get a sense of this. But I think across all of these domains, and there are more that I didn't have a nice picture for, the general idea is that really over the last 5 or 10 years only, there's been sort of vast quantities of digital data coming from even the world's poorest and most sort of remote regions. And it tends to come from two primary sources. One is orbiting things, remote sensing, satellite imagery, night lights, and so forth. And the other is through mobile phone networks. And so what you see is a lot of really promising and powerful applications that take the data generated by those new sensors and new technologies and use them to provide insights, not just into social science research, but also into policy. So maybe next slide, I'll talk about one concrete example. This is something that really has taken on a lot of, it's an area that I've been working in for several years, but has become suddenly much more relevant in a practical way. And the context is the COVID pandemic in developing countries, where there is this rapidly growing crisis where I think the World Bank estimates that about 150 million people will be facing food insecurity because of the pandemic. And so, everywhere around the world, people are suffering, but in developing countries where a large portion of the population is already living at subsistence levels, when you sort of force them to stay at home and stop them from traveling and working, that really quickly translates into food insecurity. And so this line of work is focused on using new methods from AI and machine learning, as well as new sources of data to help target government response to COVID. So, one very concrete example, we're working very closely with the government of Togo, who received a large amount of money from the World Bank in order to finance cash transfers to poor people. But they face this very difficult question of how can they prioritize, there's 7 million adults in Togo, about half of them live below the poverty line. They can only afford to provide transfers to maybe 10% of the total population. It's a very difficult problem for them to identify the people that should get those, should be sort of first in line for support. Particularly because they don't have a centralized government poverty database that allows them to say, oh, this 10% of the population are the poorest 10% of the population. So the work we've been doing has been leveraging data from satellites and from mobile phone networks to help the government identify the poorest regions of the country. And within those regions, the individuals that, the individual subscribers that are likely to be in the most extreme poverty. And then those algorithms are used to provide, directly provide mobile money transfers to currently about 550,000 individuals. So I think this is just one example of how, this is the sort of work that wouldn't have been possible 5 years ago because you just didn't have that sort of data at scale or the technology to apply that data to this very practical social problem. Next slide, please. So stepping up a level, the courses I teach are, there's this graduate seminar on the right that's really myopically focused on applications of big data and machine learning to international development. It tends to draw mostly PhD students and also a handful of other graduate students. It's really a research-first seminar. And then on the left, I teach a much larger graduate class on applied machine learning, which is, there are several different options for taking machine learning classes at Berkeley, from very, very theory formal courses where you spend most of your time proving the consistency of estimators and deriving, theorems to ones that, entirely take canned tools like data analysis packages and apply them to data. My course is sort of in between. So it's mostly in Python. Students implement the algorithms themselves, but the focus is really on like helping students gain intuition for how they would apply machine learning to data. Yeah, and again, I think that's my last slide, but happy to stick around for some questions if there are any.